Hello everyone, myself Krishna Pranav. I am from ITA first semester and today I am going to present on EC. My topic is conditioning of water. Objective. The purpose of conditioning is to transform raw or partially treated water into a form that behaves well in the systems that depend on it. Boilers, cooling towers, pipes, filtration beds, even plain all old household appliances. The intent isn't just to make water clean, but to make it cooperative, to prevent scale deposits, corrosions, and fouling, to ensure chemical stability suitable for industrial processes, to improve taste, odor, and aesthetic qualities for domestic use to maintain the lifespan of mechanical systems that rely on water flow, to protect the environment by reducing harmful discharge. Water conditioning becomes a kind of quiet negotiation between chemistry and engineering, persuading the water to stop leaving mineral graffiti everywhere it goes. Introduction. Water is its natural form is rarely ideal for industrial use. It carries dissolved minerals, gases, organic residue, microorganisms, and suspended solids, each capable of causing damage when exposed to heat, pressure, and metal surfaces. Industries therefore condition water, turning its composition into a musical tunes, an instrument before a performance. Conditioning of water involves physical, chemical, and mechanical treatments to improve water quality. By doing so, industries lower maintenance costs, increase energy efficiency, and prolong equipment life. The process transforms ordinary water into a controlled medium, predictable, safe, and stable for use. Requirements. To condition water properly, several ingredients are and tools are enlisted. Softening agents, ion exchange resins, chelating agents to remove calcium and magnesium, coagulants or flocculants to gather tiny suspended particles into removable clusters, filtration media, sand, activated carbon, multimedia beds to trap impurities. Disinfectants, chlorine, UV systems, ozone to silence microbial itchers, pH adjustment compounds used to nudge acidity or alkalinity into a stable zone, monitoring instruments to read hardness, turbidity, conductivity, microbial load, and pH. Conducting often requires both chemical and mechanical elements, a duet instead of monologue. Expression used. Water conditioning is generally analyzed through key parameters. Hardness as CaCO3 equivalent. Hardness equal to mg of Ca plus 2 plus mg plus 2 by L of sample. Alkalinity ALK equal to OH minus plus CO3 2 minus plus HCO3 minus. Softening reaction example Ca2 plus Na2CO3 gives rise to CaCO3 plus 2Na. Ion exchange representation 2RNA plus Ca2 plus gives rise to R2Ca plus 2Na plus. These expressions show how chemical interactions of alter water properties. Technology and meteorology. Water conditioning blends classical chemical with modern optimization. Some widely used methodologies include ion exchange, hardness forming rock ions Ca plus 2, Mg plus 2, swap places with friendlier ions like Na plus. It works like a polite exchange of seat in a crowd train, so everywhere behaves better. Reverse osmosis, RO. Water is pushed through a semi-permeable membrane that rejects salts, metals, and molecules too large to pass. RO acts like a deserting gatekeeper. Activated carbon treatment. Organic impurities, odor, and chlorine cling to the porous carbon surface. It works quietly. Adsorption is suitable, but though chemical precipitation. Additives encourage problematic ions to form solid particles that can be filtered out, a bit like coaxing dissolved minerals to come out of hiding. Aeration exposes water to air to remove dissolved gases, oxidize metals like iron, and freshen the overall quality. Disinfection UV rays, ozone, or chlorine eliminate pathogenic organisms. This creates water that is not just clear but genuinely safe. Explanation: water conditioning acts like a quiet guardian in the industrial world. It prevents minerals from forming stubborn layers inside boilers, stops corrosive ions from eating away metal pipes, and ensures equipment runs with a steady grace of a well-oiled machine. Industries use conditioning methods such as lime soda process, removes carbonate and non-carbonate ordnance by forming insoluble precipitates, zeolite softening, exchanges calcium and magnesium ions with sodium ions. Ion exchange demineralization removes almost all dissolved ions, producing high purity water. Internal treatment. Injecting chemicals directly into boilers to prevent scale and corrosion. Dehalation. Removing oxygen and CO2 to prevent rust. Each method tunes the water like adjusting individual strings of an equipment until harmony is reached. How it will help us? Water conditioning improves the reliability and efficiency of industrial operations by preventing scale in boilers and heat exchangers, reducing corrosion in pipelines, improving heat transfer efficiency, lowering fuel consumption, extending equipment lifespan, minimizing downtime and maintenance, providing consistent operation under varying raw water conditions, ensuring safety in high pressure systems. In short, treated water becomes a trustworthy partner in the manufacturing process. Simplified reaction process. Hard water remove Ca plus 2, Mg plus 2, then reduce hardness, conditioned water, another view, minerals, react or exchange, precipitation or removal, clean water. Merits prevents energy due to scaling, removes, improves lifespan or machinery, reduces chemical or fuel consumption, produces high quality steam, prevents costly breakdowns, reduces health hazards in cooling systems, enhances overall operational efficiency. Demerits: some treatments require expensive chemicals. Ion exchange resins require periodic regeneration. Improper conditioning can cause serious corrosion. Sludge disposal from lime soda process can be challenging. High purity water system need careful monitoring. Overdosing chemicals may contaminate systems. Result: after conditioning, water source reduce hardness, stabilize the pH, lower dissolved solids, fewer corrosive ions, improved suitability for boilers and industrial systems. This results is less scaling, better heat transfer, lower maintenance, and increased operational reliability. Conclusion: conditioning of water is a critical step in any industrial process involving heat, steam, or metal contact. By employing chemical, physical, and mechanical treatments, industries ensure that water behaves predictably and safely. Properly conditioned water reduces operational cost, increases equipment lifespan, and ensures smooth industrial performance. It is not merely treatment, it's preparation, refinement, and protection woven into a single system. These are the references. Thank you.